For Laplace transform, you have some formulas that you have to refer while solving the questions. Now see, if they have given like this, find Laplace transform of this, okay, then what you need to do, write L in the bracket, write what they have given, then make it separate, okay, each term you have to write separately, and then for each one you have to write like this. If it is L of 9, then take 9 as common, 9L of 1, okay, then for each you have some formulas that you have to do it in the step 2. See, for 9 L of 1, you have 9 into 1 by s, okay. Laplace transform of 1 is 1 by s, so you will write 9 into 1 by s, which is 9 by s. Similarly, for all others you have those standard formulas, you have to see that and write accordingly. Then after doing all of that, you have to substitute back all that in the equation, okay. This all which you got, substitute back here, okay. Then after substituting the answers, you will get the final answer. There are three properties of Laplace transform. First one is shifting property. Suppose the Laplace transform they have asked in the question is having E also, okay, then how you need to solve it? It's the same thing, but it's a bit different, slight difference is there. In step 1 you will find the Laplace transform of what is with E, this cos 2t. Find that cos 2t Laplace transform and write as f of s, okay. Then in step 2 you have to find this Laplace transform, write it as L of e power 4t into cos 2t, that is equal to f of what E power has. It has 4, right? So write f of s minus 4. How you will find f of s minus 4? What is f of s? In place of s you have to substitute s minus 4. So here also you will substitute s minus 4, and in this also you will substitute s minus 4, and that's the answer for this question. Second type of Laplace transform which can come in exam is t raised to n form, okay. Like suppose this is the question, find Laplace transform of t cos 2t, okay. In this what you need to do, in step 1 you need to find the Laplace transform of cos 2t and write as f of s. In step 2 you have to find the Laplace transform of t cos 2t. How you will do that? See, t has the power of 1 here, so you will write minus 1 power 1 and d by ds power 1 of f of s. F of s is this, right? So you will write it like this. If it is t square, you will write minus 1 power 2, and you have to find the second order differential, means d square f of s by ds square, okay. In that way you need to find the answer. Third type of the question is L of f of t by t. Suppose L of sin kt by t. If t comes in denominator, what you need to do? Step 1, find the Laplace transform of sin kt, that you will have k by s square plus k square, that is f of s. In step 2 you have to do like this. If it is divided by 2, you need to find the integral of what you got here, okay. Integral s to infinity this f of s, and after doing that integral you will get the final answer. A periodic function of period 2a is defined by f of t is equal to this one, okay. Now what you need to do, you need to prove that L of f of t is equal to tan h as by 2 by s square. Now how you need to do, in step 1 you will write L of f of t, okay. Now L of f of t, this is a standard formula, you have to write it down, and then you have to note the interval. Interval given is see here, it's 0 to a to 2a, so the interval is 0 to 2a. That interval you will note it down. So if it is 0 to 2a, then capital T will be 2a, okay. Then capital T you have to substitute in that equation. After substituting, you will have this 1 by 1 minus e power minus 2as, and 0 to 2a, this will be the same. Then in step 2 what you have to do, you have to substitute the values as from 0 to a, it is some value, right? F of t has some value, and a to 2a, separate it and write the value of f of t in 0 to a. See, in 0 to a, what is the value of f of t? In 0 to a, the f of t value is t, so you will substitute it as t here. See, f of t is substituted as t, then f of t is substituted as 2a minus t in interval 2a to 2a, okay, according to what they have given. After doing that, just the simplification part, and you will have the final answer at last. Then after this step you have to prove something here. See, you got 1 by s square into this, right? Now but you had to prove something else. See, you have to prove this. Now how you will get this? See, s square you got, how you will get tan h as by 2? With s square you had this term. Now what is sin hx? It is e power x minus x by 2. Similarly cos hx, what is tan hx? Sin hx by cos hx. So you will divide these both and you will have this here, okay. Now observe carefully, divided by e power x. When you divide it by e power x, it will be of the form 1 minus e power minus 2x by 1 plus e power minus 2x, the same form which we have in the question. Now see, observe here, it is e power minus as, okay, but here it is e power minus 2x. So what we can infer from that, if tan hx is there, if x is here, it is minus 2x here, okay, if x is there, it is 2x. So in the proving part, you see what we need, tan h as by 2, right? So as by 2 we will have as, so this minus as can be written as h as by 2. So we will substitute this in the final equation, so we will have this part, okay. You will be given a question of this type, which will be having one function here and u of t minus 1, okay, t minus 1 or t minus 2 or anything, t minus a. Now what you need to do here in step 1, whatever will be with u of t minus 1, that you will consider as f of t minus 1, okay, that will be f of t minus 1 here, and then replace t by t plus 1 always, okay. When you replace t by t plus 1 here, see, f of t minus 1 is e power t minus 1 plus sine of t minus 1. Now replace everywhere where you have t as t plus 1. So when you substitute here t plus 1, you will have t plus 1 minus 1, and here also the same, and when you will cancel plus 1 and minus 1, you will have f of t, you will get f of t here. In step 2 what you need to do, find the Laplace transform of f of t, which you got here, okay, substitute this here, okay, then you will get this and separate it and find the Laplace transform. After doing that, in step 3 what you need to do, just you need to see here L of f of t minus 1 into u of t minus 1. How you will do that, whatever be here, like if it is minus 1, you will write e power minus 1, okay, if it is minus 2, you will write e power minus 2 s will be there only, okay. What you will have here, that power you will put here, then write the same thing which you got here, L of f of t, okay. In that way you need to do for all questions in unit step function. This is another type of unit step function, which is heap side function, okay. In this, the question will be of this type, okay, f of t is equal to 3 categories they will give, and this intervals they will give. In step 1 what you need to do, write the standard formula, okay, this is the standard formula. After writing this, find out what is f1, f2 and f3. This is f1, f2 and f3, 1 t and t square. A and b, what is a and b, from 0 to a to b, then b. So a is 1, b is 2. Note down all this. After noting down, you have to substitute this in this formula, okay. When you substitute that, you will get here this one, f of t, this all things when you substitute accordingly in this formula, you will get these things, okay. Then what's your step 2? In step 2 you need to find the Laplace transform of this whole thing. Take L on both sides. After taking L on both sides, make it as equation 1, then separate it and find the Laplace transform of each of the following. L of 1 Laplace transform you will find, it is 1 by s. For next L of t minus 1 into u of t minus 1, how you will do this? Take whatever is with u as f of t minus 1, okay, then substitute t by t plus 1, same as in the previous question what we did, right? Same like that you have to do. Find f of t, then find L of f of t, then if it is f of t minus 1, substitute the power of e as minus 1 s and copy that here, and that you will get as e power minus s by s square. Same thing you need to do for this also. Here what is with you, you will take as this f of t minus 2, because it is t minus 2 here, then do the same things, okay. Then you will get see, it is t minus 2 here, so e power minus 2, and this L of f of t you will write here, and you will get these things. Then substituting all these 3 L which you got in this equation in one equation, you will have this answer, okay, and that's the final answer which you will get for this question. The question is to find the inverse Laplace transform of the following, this one by direct formula, okay. See, you have to observe, if you can't have direct formula, there are 2 more types, you have to go for that. First you have to check if it is possible by direct formula or not. See, in direct formula what you will do, you will separate this as s square by s cube minus 3s by s square plus 4 by s cube. After writing all this, apply L inverse on all the sides, see the formula, it has all standard formulas, and write the answer, okay. This is by direct formula. For this question you don't have any standard formula, so what you will do, you will complete the square. By completing square method you will do this, okay. In step 1 what you need to do, see here, take the denominator, it is s square minus 4s plus 13. It is of the form a square minus 2ab plus b square. Okay, compare that and write that what is a, what is b. Okay, see, when you compare, you will get a as s and minus 2ab as minus 4s. So in that you will get b as 2. Okay, when you get b as 2, find b square. B square is 4, right? So add b square and subtract b square in this, and you will have this answer here. Then take plus b square common with this, and with 13 take minus b square. Okay, so you can factorize this and write it as s minus 2 whole square plus 9. Then it can be written as s minus 2 whole square plus 3 square. That's the step 1. You factorize the denominator. In step 2, you will substitute that in the denominator as what you have got. Then after that, what you need to do, see, in denominator you will have s minus 2 square, right? So in numerator also you need to have s minus 2. How you will do that? Add and subtract 2. When you will add and subtract 2, take that minus 2 with s and rest all the things separate, and you will have this, and you can write it as s minus 2 plus 4 by s minus 2 whole square plus 3 square. Then in step 3, what you need to do? In step 3, you will find the Laplace transform of this. Okay, when you will do that, see here it's s minus 2, right? So you will write what is s minus 2, so that 2 you will put in e. Okay, and write that s minus 2 as s. Okay, like that you have to do, and separate this like L inverse of s by s square plus 9, then L inverse of 4 by s square plus 9. Then after separating, you have to find the Laplace transform of each of this and substitute it in the final answer. The third type is by partial fraction method. Okay, in that you will have of this form, it will be already factorized, so you will have to use partial fraction method. In this step 1, what you will do, you will write that as normal partial fraction, and then find ABC and substitute that ABC in this equation, and then find the L inverse of each of these separately. Okay, that's pretty simple. Convolution theorem is also very simple. The question will be given like this, using convolution theorem, and you will have to write in step 1 f of s into g of s is equal to, separate this what they have given into two parts. Take one as f of s and another one as g of s. Then find the Laplace transform of each of this. Okay, you will have there sin t and 1 by 3 sin 3t. After finding f of t and g of t, in step 2 you have to write the formula. This is the formula, and there you will substitute what you have got, f of t and g of t. Okay, see, in this formula f of t is sin t, right? But it is u, so we will write sin u, and g of t minus u means sin of 3 t minus u. You will write here as t minus u. Actually, I have missed it out. You have to actually write here sin 3 of t minus u. Okay, then find the integration, and that's your final answer. Okay, for differential equation it will be of this form. Okay, they will give a differential equation, they will give 2-3 conditions. Step 1, you have to take L on this side and L on both the sides. Okay, so here it will be L of 0, and here it will be this. For all of this, the third order y and second order, first order, and y, you will have all the standard formula. Okay, this one, this one, this one, and this one. Okay, and L of 0 is 0. So you will substitute all this, and you will substitute what is given in the equation here. See, y dash of 0 and y of 0 is 0. So where all y of 0 and y dash of 0 is there, substitute 0 there, and y double dash of 0 is 6. So substitute there 6, and finally you will have remaining as s cube, s parts, and L of y. Okay, take L of y as common, and you will have this s parts here and minus 6 here. Find L of y. In step 2, what you need to do, find the inverse. Okay, by using partial fraction method. Here you will factorize this and write in the denominator, and use partial fraction method to find the L inverse. Okay, for Taylor series, the question will be of this type. Using Taylor series method, find the value of y at x is equal to 0.1 and x is equal to 0.2. For two values of x, you have to find y. For the initial value problem, dy by dx, they will give x square y minus 1 and y of 0 is equal to 1. Now first step, what you need to do, see, write what you have to find. You have to find y at 2 points, at this and this. Then what they have given, dy by dx, y naught and x naught. What is y naught and x naught? See, this is dy by dx, you can write as y1 is equal to x square y by x square y minus 1. Then y of 0 is equal to 1. If they give like this, what does that mean? Y naught, this is y naught and this is x naught. Okay, you will write y naught is equal to 1, x naught is equal to 0. After finding all this, you have to follow a series of steps, which is write y1. y1 is equal to x square y minus 1. Okay, then you have to find y1 of 0. y1 of 0 means substitute the value of x naught and y naught here. Okay, after doing that, you will get y1 here. Okay, then y2, how you will find? Differentiate this with respect to x. Okay, after differentiating, you will have here this one. Okay, y2. In that also you need to find y2 of 0. For x, x naught, y naught and y1 value which you got, substitute all that, you will have, I will have this final value here for y2. Do the same for y3 also and for y4 also. Then you will have all the values from y1 to y4. Okay. Step 3, you have to write the formula of y of x. This is the formula, and in that substitute the values of y0, y1, y2, y3 and y4 at 0, y4 of 0, y1 of 0, all that which you got now, substitute that and you will have that final equation here. Okay. Then what we need to do, we had to find y, right? Y at 0.1 and 0.2. So when y, see one equation you got here, y of 0.1 means wherever x is there, put 0.1 and find the value. Similarly for 0.2 also. In this method, the question will be of this type: find y of 0.2, correct to 4 decimal places for the equation y1 is equal to x minus y square and y of 0 is equal to 1. That means this is x naught and this is y naught. Okay, and this is dy by dx, and h is given as 0.1. Step 1, you have to note it all what they have given. Okay, then in step 2, you will write f of x comma y is equal to what y1 they had gave, right? That you have to write. Then you have to substitute x naught and y naught as this one, substitute those values and you will have minus 1 here, that is f naught. Okay, f naught you will get as minus 1 here. Then you have to find x1 and y1. Okay, x1 means x naught plus h, that is 0.1. y1 means y of x naught plus h, which is y of 0.1. Then y1 of 0, that means y naught plus hf naught. Okay, substitute those values, you will have the answer here as y1 of 0 is equal to 0.9. Then in step 3, you have to make a table with 4 columns, which is x1, y1, f1 and this is next y1. Okay, then this is x naught plus h, fill all those values here. Then y1 is which you got initially here 0.9. Okay, that you will put here, and f1 of f1 is equal to x minus y square. Use this x and y values to find f1, and then f naught you had got right before, substitute that, and f1 also along with y naught you will get one value here. In next step you will use this value here. Okay, then you will find the same and do this for 3 times. Okay, after doing that you will write y of 0.1. see, this is x, right? Y of 0.1 is equal to 0.9133. what value you get at last here, that will write like this. Then in next step what you have to do, repeat the same. We had to find for y of 0.2. here we got y of 0.1, right? See in the question. In the question it is given y of 0.2. Had they give 0.1, we had to do till that stage only, but it's given 0.2, so we need to do it again. Okay, the things are similar now. This dy by dx will be same. Y of 0.1 will be written as this. Now x naught will be 0.1 and y naught will be 0.9133. h will be that same. y1 will be x minus y square, the same thing. Okay, now f naught will be according to this new x naught and y naught, which is minus 0.7341. Then you have to find x1, which is x naught plus h. Now x naught is 0.1, so the answer will be 0.2, and y of x naught plus h, which is y of 0.2, this we need to find. Then y1 of 0, which is y naught plus hf naught, substitute those values, you will have the answer as 0.8399. Make this same table. Here you will write now 0.2, y1 which you had got before. Then using these two values find f1, using f naught and f1 find out y1 for each of these case, do this 3 times until you get 2 similar values, then that's the final answer. Y of 0.2 we had to find, and you will get at last here, that's the final answer. RK method is also the same, just a slight difference is there. The question will be like this, they will give to find y at x is equal to 0.2, dy by dx they will give, and y0 and x0 values and h value. Okay, note down all of this. Then here will be the difference, you have to find k1 also here. K1 is h into f0, you will have f0, substitute those values, you will get k1. Okay, k1 is 0.2. In step 2 what you need to do, make this table with 4 columns, x, y, f and ki. In these 4 rows you will have x0 is equal to 0, x0 plus h by 2, x0 plus h by 2, x0 plus h. Here you will have the same, but here it will be k1 by 2, k2 by 2 and k3. X and y values, using these to find f values, and then ki means hf. H will be the same 0.2 in all the cases, f will be what you will get here, that one you will substitute here and you will get the answer. After finding all of this, in step 3 write the formula of k, substitute the values of k1, k2, k3 and k4 and you will get one answer. The final equation is this, y is equal to y0 plus k. Substitute all these values and you will have the final answer as 1.2428. This is Milne's predictor corrector method. You will start from here. You will have to find y at 0.4. They will give you one equation and this table they will give you. Observe, in this table x0 values will be like this, x0, x1, x2, x3, these all values, and y0, y1, y2, y3 will be these values. Hence they will give you here. In step 1, write what equation they have given and find f0 till f3. f0 will be f at x0 and y0. Okay, by using these two values, substitute in this equation, you will get f0. Similarly for all of this you have to find. After doing that, you have to find this y4p which has this formula, substitute y0, f1, f2, f3, you will have this answer. Then you need to find f4. f4 how you will find? By substituting x4 and y4. Now x4 is this, what in question they give, okay. 0.4 is x4 and y4 what you got here. Substitute that in this equation, x4 y4 plus y4 square. You will get one answer here, that is f4. Now this formula is for corrector of yc. This is y4 of c, that has one formula, in that you will have f4 also, that you substitute and you will have an answer here, that will be your final answer. Okay. This is the type 2 of predictor corrector method, which is Adam-Bashforth method. In this they will give you this question and this table similar to as before. This is the equation. In step 1 what you have to do, write the equation f is equal to half xy, find f0, f1, f2 and f3. Then in step 2 you will have one formula for y4p. Substitute all these values, okay, which you got here, and you will get y4p. After that find f4. f4 is x4 y4 by 2. x4 is what they gave in the question to find, that is 0.4. okay, that you will get f4, and y4c has this formula. You have all these things, when you substitute you will get the final answer. This is the same RK method which we had in the previous module. In this we will have one extra term which is y dash. So how we need to do, they will give one equation here and values of y0 and x0 here, okay. This is z0, we will take y dash as z. Now we need to find this at x0 is equal to 0.2, h value they have given. Note down all what they have given and make a table like this. You will have the values of x, y and z, ki, g and li. Here you will have x0, x0 plus h by 2, x0 plus h, y0, y0 plus k1 by 2, k2 by 2, k3, z0, z0 plus l1 by 2, z0 plus l2 by 2, z0 plus l3, same as this. Now ki is h into z, h will be same, z what all you get here, that you have to write down here, okay. by seeing that value of z. See, z naught is this, right? See, z naught they will give you here, that is actually this one, y dash of x naught is equal to z naught. So, here you will get the z naught value. So, substitute that z naught value here, x naught value, y naught value and z naught value, and find k I. Then g will be that equation which they give you. See, keeping y double dash here, shift all of this here, that y double dash is nothing but g. So, you will have x z plus y, z is y dash, okay. Then find li, li is h into g. G what you will get here by substituting the x, y, z values of this, that will be g, and multiply by h you will have li. Then in next equation you will use this li and ki values here and here, okay, like you need to do for 4 steps. In step 3 you will have this formula y of x naught plus h, which is 0.2. This is the formula. Substituting the k values you will have the final answer. Similarly for z also, the final answer you will get when you substitute L values. These two things which we had to find, which is y dash of 0.2, z means y dash, and y of 0.2. By using Milne's method, they will have given all these values. This is what we need to find, and this is the equation. See, these are the values of y of 0 is equal to 1, means x naught, y naught, y dash of 0 is equal to 1, x naught and z naught. Like that for 0.1 means this is x1, and if it is y, it is y1, if it is y dash, it is z1, okay. In bracket it will be always x terms, and outside it will be either y or z depending on this. Then you need to make this table. Here this and this rows, this and this columns value will be always same. This is x, y, z initial values. By looking into these values you have to fill this, okay. Suppose x is, this is x naught, right, put here 0, and y naught is 1, z naught is 0, f is equal to z, g is equal to, substituting these values you will get g. Then in next one, y of 0.1 is this is x1, substitute that here, this is y1 here, this is z1 here, okay. Then again you will find g, do that till 0.3. Then you have to find y4p and z4p using these formulas. Substituting all these values you will get these two answers. Then you have to find f4, f4 is nothing but z4, this which you have got, that will be the same. G4 means values of x4, z4 and y4, you will get the answer here for G4. In the last step what you have to do, using these two formulas you have to find y4c and z4c, alright. Coming to the proof of Euler's equation, first you need to write one sentence here, okay. That is, a necessary condition for I integral from x1 to x2 f of x comma y dash dx to be an extremum is del f by del y minus d by dx of del f by del y dash is equal to 0. They will give you in this question only, you have to just copy it down from the question to the answer script, okay. Then next thing you have to write here, proof. You have to start the proof by making a diagram like this, okay. This is y axis, this is x axis, okay. Mark 2 points A and B. A will be having x1 and y1 coordinates, B will be having x2 and y2, okay. Then join these two lines and then write it as y of x. Then make some random line like this and write there, this is also y of x, but a small difference, epsilon plus eta x. This is very important, epsilon plus eta x, okay. Then after doing that you have to write some points here, x is equal to x, y is equal to y of x, this thing, plus epsilon eta x. Then y dash is equal to y dash of x plus epsilon eta dash x. After doing this you have to write I is equal to this what they have given here, x1 to x2 f of x comma y dash dx. Then you need to substitute the values of x, y and y dash in these places. Okay, write the same, x is equal, I is equal to, after copying it down from here you have to differentiate it with respect to epsilon. Di by d epsilon is equal to, inside this you will write del by del epsilon f of this same thing here. After that step, the next step is to expand these f terms. When you differentiate it with respect to x, what you will write here, x1 to x0, x1 to x2 d by del x. Okay, if it is with respect to x, you will write del by del x, then here f into del x by del epsilon. Okay, like that. If it is for y, what you will write, del f by del y into del y by del epsilon. Similarly for y dash, del f by del y dash into del y dash by del epsilon. Okay, after doing this you have to write the next step here. See, first term will get cancelled because x is a constant here, and these two terms will be remaining. You will separate these two terms in the integrals. Okay, like this. After writing this, you have to make a substitution here, which is this del y by del epsilon, you have to write it as eta of x, and this dash part as eta dash x. Okay, this is equivalent, and this you will write the same here. In this one you have to integrate by parts. Take this as first function, this as second function. Okay, when you will do that, what you will have, keep it like that only. Then you will integrate it. Okay, this is dash here, right? When you integrate, what it will be, this one minus, differentiating this with respect to x, d by dx you write here, then again integrating this, you will get the same thing here. Okay, now one thing you need to see here, the limits are from x1 to x2. Okay, but we know that eta x1 is equal to, this you need to remember, eta x1 is equal to eta x2 is equal to 0. So when you substitute the limits also, it will be 0 only term remaining will be this. Okay, then along with this write this term. Okay, it will be like this, copy it down here. After taking this term here common, because the limits are common, you will get these terms. Okay, here you have this term and this term as common, you can take it out. When you take this eta of x as common, you will get this term, and we know that di by d epsilon is equal to 0. So this term will be equated to 0. Okay, del f by del y minus d by dx of del f by del y dash, sorry, this is del y dash, I forgot to put. Okay, this del y dash is equal to 0. This is the final equation of the Euler's proof. The question is to find the extremal of this functional. Step 1, you need to write f of x comma y dash, what they have given here, write it as like this, and then partially differentiate it with respect to y. Since here there is no y, y dash is there but y is not there, this del f by del y will be 0. Then you need to differentiate with respect to y dash. When you will do that, you will get here 2y dash by x cube. Okay, then in step 2 you will substitute this both in this equation. Okay, Euler's equation. When you will do that, you will get this one. Then dx you shift here and integrate both, then shift it here and again integrate it, you will get 2y is equal to c1 x power 4 by 4 plus c2. You can stop here also, but if you would make the constants more clearer, it is more better. You have to see, this is the same thing here, y you will keep here only, 2 you shift here, it will be this one, and take this whole term as c4 and c1 by 8 as c3, then you will have this y equation. For all the questions you need to follow this same procedure. There are total 3 questions, 2 from geodesic and 1 from hanging chain, okay, which can come in exam. They will give you either of these 2 questions and you have to find the geodesic solution. In step 1 you will write this formula. Okay, remember this formula for geodesic, and then what you have to do, this is f of x comma y dash. Then find del f by del y, the same thing which we had done previous problem, and then substitute that in this equation and then shift and integrate here. See here I took the root k as constant, so it will make the things more easier. Okay, in this question you have to make this as root k. Okay, I could have taken c1 also, but root k will make the things more simpler. You can see how. Okay, just do these same things. Y dash, that will be m. If y dash is equal to m, that means y is equal to mx plus c. Okay, y dash means dy by dx. Okay, slope is equal to m. If slope is m, that's a straight line. Y is equal to mx plus c. We had to prove that it is a straight line. Okay, see they will give the arc length like this. You have to use this formula here. Okay, do the same thing. F is equal to, write this and find del f by del y as well as del f by del y dash. Then use that in the equation, shift and integrate in this form, and then you will have the final equation here. Okay, here I took as k. Okay, after that integrate it and at last put it in this form. Shift C here and make it a square here, then it will be a equation of the form of parabola. Okay, in hanging chain topic you have just one question. This we have to prove it is a catenary. Okay, you have to remember this equation, and this is a bit modified Euler's equation, which is equal to f minus y dash del f by del y dash is equal to constant. Okay, this you have to remember. Why? Because f is independent of x. Then you will substitute the value of f here. Okay, this value, and here also. Then partially differentiate with respect to y dash, and you will be having the same things here, and the same things, all are the same things. This you will integrate here. Okay, when you integrate this, that is the cos h inverse of y by c. Okay, then you will take cos here and you will have this final equation. Okay.